this is Mr. Manley. In this video, I'm going to be looking at complex fractions. What is a complex fraction? It's a fraction of a fraction. Doesn't need to be this complex. If I did 1 over 2 over 5, that's a complex fraction. It's a fraction of a fraction. I'm going to show you one way of working with these. There's another way, which I'm not going to talk about, so as not to confuse things. Whenever I see a complex fraction, I want to get rid of the denominators. I want to multiply by some form of 1 that gets rid of the denominator. And the form of 1 that I'm going to multiply by is the least common multiple of the denominators. And by the denominators, I mean the 15, the 5, and the 9. So what's the least common multiple? The least common multiple of 15, 5, and 9. You might pause and see if you can do that. That's something that students learn in algebra, maybe even pre-algebra. How do I do it here? I'm just going to start taking factors. So 3 is a factor of 15 times 5 is a factor of 15. Now I'm not going to do times 5. So I'm not going to do times 5 here because I've already got this 5. So I don't need another 5. Times, well, the 9 has 2 3's. One of the 3's is there, but I do need the second 3. So there. So that's my least common multiple. I could just say it like that, 3 times 5 times 3. I could say it like that. I could say it's 45. I think I'll keep it as 3 times 5 times 3. And remember what I said. I was going to, back here, I was going to go least common multiple over least common multiple. That's the plan. So I'm going to set that up now. 3 times 5 times 3 over 3 times 5 times 3. All right, so what happens? This gets distributed to both of these terms. Look at that. When it distributes to the first term, here to here, 15 cancels with 15, leaving 3 times 7, which is 21. Okay, so I've got 21 plus, now I distribute this to this term, and the 5's cancel, leaving 3 times 3, which is 9. Over, and then I do my distributions here, this to this. Well, there's no denominator, there's nothing canceling when I distribute to the 2, so that's 45 times 2 is 90. And then distributing this to this, the 9 cancels with 3 times 3, leaving a 5 times 2, which is 10. And I've got 30 over 100, which is 3/10. Complex fractions. Let's look here. 1 minus m to the negative 1 over 1 minus m to the negative 2. So the complex fraction is hidden in here, right, by the negative exponents. Be careful with this. Someone might want to do this. They might want to go 1 minus m squared over 1 minus m. Do you want to do that? Can you imagine why someone would want to do that? It's not correct. If I had, say if I had 5 times m to the negative 1 over 2, there I could say that's equal to 5 over 2m. See so people understand that the negative exponent means reciprocal, and I can move that across the fraction bar. Someone might understand that. But back up here with what we're given, the 2m terms, this is tied by that minus sign. It can't get across the fraction bar because it's tied to the 1. So what to do? One minus 1 over m over 1 minus 1 over m squared. Complex fraction. Fraction of a fraction. Then I'm looking at what's the least common multiple of the denominators. What's the least common multiple of m and m squared? Well, I hope that's pretty simple for you. It's m squared. So I'm going to multiply by m squared over m squared, distribute, and I get m squared minus m over m squared minus 1. Not done yet. I can simplify this by factoring. See the difference of squares in the denominator? And then I've got a common m minus 1. So that takes us to m over m plus 1. So that's it. Complex fractions. My method is to use the least common multiple of the denominators and the identity property of multiplication, which says that I can multiply by 1 anytime I want. And yes, m squared over m squared is a form of 1. Yes. Three times 5 times 3 over 3 times 5 times 3 is a form of 1. And that's my method for complex fractions.